Welcome to The Explainer. Today, we are going to tackle something absolutely mind-blowing. We're talking about one of the most complex manufacturing processes on the entire planet, how we turn a simple grain of sand into the literal brain of our modern world. I mean, just stop and think about it for a second. That phone in your pocket, the giant data centers powering AI, the electric car you might be driving, even your TV. Every single one of them depends on this one tiny, unbelievably complex invention. And it all kicks off with this: sand. A material so common, so everyday, we don't even think about it. So let's follow this incredible journey and see how it gets transformed into, really, the absolute pinnacle of human engineering.
Okay, so before we jump into the how, the nitty-gritty of making a chip, let's take just a second to talk about what a semiconductor actually is. Why is this thing so important?
And this is the magic trick. It's all about being able to control electricity, to switch it on or off with incredible precision. And that simple on-off state, well, that's the ones and zeros. That's the fundamental language behind absolutely everything digital, from sending a text message to training the most powerful AIs. All right, so the journey starts by taking that raw sand and creating an absolutely perfect, ultra-pure foundation. It's like you can't build a flawless microscopic city on a bumpy, flawed piece of land, right? It has to be perfect. And this process is just wow. We're literally going from molten sand to this huge, perfect, single crystal pillar of silicon. Then they take diamond saws and slice it into these impossibly thin, shimmering discs we call wafers. And the level of precision here is just staggering. I mean, one tiny scratch, one microscopic defect, and the whole thing is ruined. So you can think of this next step like priming a canvas before you paint. A super thin, protective layer of oxide is grown right on top of that silicon. It acts as a shield, protecting that perfect surface, and it also insulates everything, stopping electricity from leaking where it shouldn't once we start building. Okay, now for the main event. We've got our perfect foundation, the wafer. Now it's time to build this insane, multi-story skyscraper of a city, packed with billions of tiny little inhabitants, the transistors, all on a surface smaller than your fingernail. It's wild. So this is really the heart of the whole process. These 4 basic steps get repeated literally hundreds of times to build up the incredibly complex 3D structure of a modern chip. You draw the blueprint, you carve it out, you add new materials, and then you activate the silicon by basically shooting ions at it to make it conduct electricity. Let's break down how each one of those works. The first step, photolithography, is kind of like photography, but for engineers. First, they coat the wafer with a light-sensitive chemical. Then, they shine a super intense light through a stencil. They call it a mask, which has the circuit design on it. Wherever the light hits the wafer, it creates a chemical reaction. You're basically developing a picture of the circuit right onto the silicon. All right, so once that blueprint is printed, it's time to do some sculpting. They use these powerful gases and chemicals to literally etch away all the material that wasn't part of the pattern. What you're left with are these incredibly intricate pathways of the circuit, all carved out with just mind-boggling precision. Next up, our little microscopic city needs a power grid, right? So they deposit these ultra-thin films of metal, we're talking stuff like copper, all over the wafer. This is what creates the miles and miles of tiny wiring that connects all those billions of transistors, letting electricity and data zip around. And finally, before any of these chips even think about leaving the factory, they go through this brutal testing process. We're talking thousands of electrical tests. Tiny probes touch down on every single chip on that wafer to make sure it works perfectly. This is the moment of truth, where they separate the winners from the duds. So you think that's the most complex part, right? Well, it gets even crazier when you zoom out from the factory floor to a global view. See, no single company, not even a single country, can do all of this by itself. It's a massive global team effort. I mean, just look at this breakdown. It's an incredible level of specialization. You've got the US handling the brainy design work. The Netherlands builds these one-of-a-kind, ridiculously complex machines to print the circuits. Japan supplies the hyper-pure materials. And then you have Taiwan and South Korea, who are the absolute masters of manufacturing these things at a massive scale. It's this deeply interconnected global dance. So all this interdependence makes you wonder, right? Why don't other countries just, build their own chip industries from scratch? Well, the simple answer is the barriers to get into this game are just astronomically, almost impossibly high. For starters, let's talk about the money. the cost is just staggering. To build just one cutting-edge factory, they call them fabs, you're looking at a price tag that's bigger than the entire annual budget of some countries. And that's just to get in the door. You have to keep pouring billions in year after year just to keep up.
But on the flip side, the economic stakes for the countries that do succeed are just enormous. Take South Korea, for example. A full 20% of their entire national export economy comes from these little silicon chips. It's literally the engine driving their whole country.
But you know what? Money isn't even the biggest hurdle. The real secret sauce, the thing that separates the winners from the losers, is something called yield. That's simply the percentage of good working chips you get off of each wafer. And a tiny difference, even just 1%, can mean the difference between billions in profit and billions in loss. That kind of expertise, you can't just buy it. It takes decades to build. It's also really important to get that not all chips are created equal. You can kind of split them into two big buckets. First, you have memory chips. Think of these like the brain's short-term and long-term memory. Then you have system chips, which are more like the brain's logic and problem-solving centers. And as you can see, different countries really specialize and lead in each of these. And here's why all this matters so much. These two types of silicon brains, they are now inside pretty much everything that's defining our future. We're talking AI data centers, self-driving cars, robotics, space exploration, you name it. Progress in these fields is flat out impossible without newer, better, more powerful semiconductors. And that brings us to the final and maybe the most critical point. This whole journey from a simple grain of sand has become so absolutely essential for economic power and for technological leadership that it's now right at the center of global politics. Because when you think about it, the country that controls the supply of these tiny little brains might just be the country that controls the future.